What's up, guys? In this video we're going to try and prove some properties of continuity. And since we've already proved a lot of properties about limits, this should be pretty easy. Here are the properties. The first is the scalar multiple property. And this is, I should say, given that f of x and g of x are continuous at x equals c. The first is that k times f of x is continuous at c. The next is the sum and difference. No need to write that. And of course this is when k is some constant. So this is going to be f of x plus or minus g of x is continuous at x equals c. This is going to be the product property, that f of x times g of x is continuous at x equals c. And lastly, the quotient property, that f of x over g of x is continuous at x equals c, of course, provided that g of x does not equal 0. I should say g of c. So that's the point we're looking at. So g of c does not equal 0. All right, let's go ahead and go prove these. So start with our scalar multiple property. If f of x is a continuous function at c, that means we know that the limit as x approaches c of f of x is equal to f of c. All we're going to do is multiply both sides by k. So we're going to multiply both sides by k, some constant. And because of our constant property with limits, we can just pull that k right in. And as you can see, because the limit as x goes to c of k times f of x is equal to k times f of c, we can say that the function k times f of x is indeed continuous at c. So that's our first proof. Let's go ahead and prove our sum and difference properties. So this is going to be f of x plus or minus g of x. So we know, because f and g of x are continuous at x equals c, that the limit as x approaches c of f of x is equal to f of c, and the limit as x approaches c of g of x is equal to g of c. Now if we're just to add these two together, limit as x approaches c of f of x plus the limit as x approaches c of g of x equals f of c plus g of c. Now based on our property of adding and subtracting limits, so why don't we just throw that minus sign in there. They'll correspond with each other. So if this is a plus, this will be a plus. If this is a minus, this will be a minus. And based on our properties for limits, we know that this can be rewritten as x, the limit as x approaches c of f of x plus or minus c, so we can, or plus or minus g of x, so we can write that in one limit is equal to f of c plus or minus g of c. And of course, because the limit as x approaches c of the function f of x plus or minus g of x equals f of c plus or minus g of c, we know that that function is continuous at c. So that proves that. Let's move on to our third property, which is going to be our product property, which is going to be f of x times g of x. So again, based on continuity, we know that the limit as x approaches c of f of x is equal to f of c, and that the limit as x approaches c of g of x is equal to g of c. Well, let's just multiply these two together times the limit as x approaches c of g of x. And we know that's going to equal f of c times g of c. And based on our product property with limits, we can just stick these inside one limit. And now it's pretty easy to see that the limit as x approaches c of the function f of x times g of x is equal to f of c times g of c. So that is going to effectively prove that. Let's get rid of this and take a look at our last property, our quotient property. And because f of x and g of x are continuous at c, again, we know that the limit as x approaches c of f of x is f of c, and that the limit as x approaches c of g of x is g of c. So let's go ahead and divide those two by each other. And again, we know we can never divide by 0, so we're going to make the stipulation that we're going to make the stipulation that the limit as x goes to c of g of x cannot equal 0, or that g of c cannot equal 0. Either of those will do, because they are, again, equal, because g of x is continuous at x equals c. And when we make that stipulation, we can use our quotient property with limits and rewrite this as the limit as x goes to c of f of c over g of c, and that, this should be f of x over g of x, and we know that that is equal to, based on our quotient property, f of c over g of c. And that shows that the limit as x goes to c of the function f of x over g of x is equal to f of c over g of c, meaning, of course, that f of x over g of x is indeed continuous at c, like we set out to prove. Oh, and this is our fourth property. So again, that proves all our properties. Pretty easy, since we already did all those limit property proofs, and they're paying off now, which is nice. But those are all the important properties of continuity.